Okay, hello everybody. My name is Marco Heiden, and my colleague and co-speaker is Philipp&Marco. We are both Apache StreamPipes PPMC members, and the title of our talk is Democratizing Machine Learning Pipelines Using StreamPipes. We will show you how you can flexibly integrate and serve models for industrial IoT applications. So what is StreamPipes? In case you're not familiar, StreamPipes is an open source industrial IoT toolbox, which enables non-technical users to connect, analyze, and exploit data streams. So StreamPipes targets non-technical users, which don't necessarily have coding experience, to connect to certain data sources and then analyze them and exploit the information that they get from the data streams. Our software has different modules, such as a connect module to connect the data streams, a pipeline editor to plug together data analysis pipelines, then a dashboard to monitor certain KPIs, and also a data explorer, which is still in the beta, which serves as a convenient tool to create what's it called, data sets to train, for example, machine learning models, or to collect data in general. Finally, the user can get notifications about certain events in the data stream, so that you can then act on the result of the analysis. So let's say, for example, that we're in a factory with this production line, and in such a factory there are different kinds of robots and cameras installed and other sensors which monitor the environment continuously, and usually such data is distributed, and it's not easy to collect them at a certain place to analyze the data. So what StreamPipes does is StreamPipes provides a convenient interface or convenient adapters to connect to the different data sources. And afterwards, we can use these combined data sources to then do analytics on them. So how does StreamPipes work? StreamPipes uses connect adapters to connect to the most well-known protocols, such as ROS, MQTT, or OPC UA. And then the collected data is available in the StreamPipes pipeline editor, which you see in the middle. Basically, you can build pipelines in a distributed fashion. So on one node in the network, we could deploy a certain pipeline which does transformations and reduces the event rate, for example. And then it forwards the result to another node, which then performs other data analysis steps. And our software is containerized, so you can deploy it wherever you want, such as Mac, Linux, Windows, and different microcontroller, different software architectures. Finally, with the results, we hope you can build useful knowledge from the data, such, for example, to calculate live KPIs and to monitor them, or you get notified if a certain event occurs, for example, if a machine breaks down. We have a toolbox of different components. One is the previously mentioned connect component with the different adapters for protocols. Then we also have a dashboard, which is a graphical user interface to quickly capture what is going on in the machine. And then we can also set up notifications for certain events that occur in our system. Finally, and this is still in the beta, is the Data Explorer, which serves as a place to explore the data and also to label the data. And then finally, one could export a labeled data set with minimal manual overhead. So how do we build a pipeline on a node in order to do data analysis? So first, we connect the data stream, which is basically simply an ordered sequence of events with our connect adapters. Afterwards, we apply data processors, which are functions that we apply to the data. So we take the data, we apply a certain function, for example, a threshold function or a certain filter, and then we forward the result to components which come next in the pipeline. Finally, we have the data sinks, which serve as the end of the pipeline. So, for example, a data sink could be writing the data into a database, but one could also forward the data plus the analysis result to other nodes in the network or to other components via MQTT or ROS or whatever. Okay, now that we know what StreamPipes is about, let's take a look at it in practice and see how we can build a data analysis pipeline and extract information from raw data.
Okay, hello also from my side. My name is Philip and I will give a short demonstration about StreamPipes and the concept that Marco talked about before. So I will start with a demo to show how you can use your own machine learning models that you have prepared or trained and use them in StreamPipes and apply them on data streams that you have connected. For the demonstration, we set up a StreamPipes instance, and now we can log into this instance and see the welcome screen here. So on the welcome screen, you can see all the running pipelines that you have in your StreamPipes instance and all the different algorithms that you have imported. Now I will go to our pipeline editor here. And here we already have integrated several data streams. So we have created an adapter before the session and connected multiple of those sources. If I go to data processors, you can see all the different kinds of algorithms that are installed and that Marco talked about. So those can be simple algorithms to filter out data or aggregate data, but you can also apply machine learning models with those algorithms, and that's the main purpose of this talk today. And in the end, we have multiple data sinks, and here you can send data to other systems or visualize it in an integrated dashboard. For the first demo, we want to use a trained machine learning model that uses data from the sensor here. So here we have a sensor box, and we trained the model to detect the state of the sensor. So here is our data source, and if I click on the description, we can also get some sample data here. So if I shake it, you can see in real time the values that are emitted by this sensor. And now we want to detect whether this sensor is shook or if it is thrown. So to do that, we select the data source and put it into our pipeline assembly and go to our data processors. Now we want to search for a parcel activity. So by entering the name up here, we can also filter our pipeline elements. And the parcel activity has a machine learning model at its core, which is trained on previous data. In the second part of our talk, we will also show how you can train your own machine learning models by presenting results from our research work. Now you can connect the data source with the pipeline element. And you can see that all the configurations like the X, Y, and Z variables are already pre-selected. In the background, we described our different values with an ontology. So we know which is the X, Y, and Z value and can automatically fill out those fields for the user. Now, once the component is configured, we can save it and we move to a data sync. So in the first step, we only want to visualize the results of this pipeline. Therefore, we use a live dashboard and connect our data stream with this dashboard and call it activity. Once we have entered the name, we can save it. And now we have built our first pipeline, which uses a machine learning model in the background. Now we can save and execute this pipeline and directly start it. Now the pipeline is executed in the background, and if we go to show details, you can also look where this pipeline is running. So tomorrow there's also another talk by our colleagues which shows how you can also distribute the algorithms. So each of those algorithms runs in different containers. And for example, also for machine learning algorithms, it often makes sense to run them as close as possible to your data source. And in this talk, they will talk about how you can dynamically change those algorithms within the StreamPipes. For now, we have a container which holds our machine learning model and applies it on the live data. If I now go to the live dashboard, I've already prepared a demo dashboard. We can add a visualization showing the current state of our sensor. Therefore, I add a new visualization, select the pipeline that we've just created, and create a single value visualization. Down here, I select the activity from our event stream and create a visualization and save it. And now you can see if I don't shake it, it is normal. And if I shake it, it shows that it is shook. And I can also throw it, and now it also says fall down. And that's a first way how you can integrate machine learning models into StreamPipes. This doesn't only work for sensor data, it is also possible to use image data. And to showcase this, we have connected a camera which films boxes containing filters, as you can see here in the live preview. So we have a camera that is mounted over a box, and now we've trained a neural network to detect those filters. And in our use case, we want to detect and locate them within the box, and also make a counter that, for example, to apply a rule and say how many filters should be within each box. To do that, you can select the filter pipeline and the filter data stream and go to the data processors. Then we have an object detection, which takes an image as an input and applies a model that detecting different objects. Here we have provided multiple different neural networks, but you can also add your own network. Therefore, you have to train the network offline, serialize it onto the disk, and then you can use it here within StreamPipes. And if I click on reload and you would have a new model, it would also show up here. Once I finish that, we now want to see where the filters are detected by our model. Therefore, we enrich our data stream with the location of the detected filters. And here we have an image and the bounding boxes which the model found before. Additionally, we also want to count our filters. So we want to see how many elements were found within the image, and therefore we count the elements in our boxes field and save that as well. And now in the end, we add two different data sinks, one to visualize the image data and one to visualize the value that the count result. Now again, we can save it and execute this pipeline. Call it image detection and directly start it. Now the pipeline is started and we will create two visualizations to see the result of our pipeline. Therefore, I go to the dashboard and here we have the visualization from before, and we can add one visualization containing our image data. So we select the image from our data stream. And also a visualization showing the count number. So we only print the value of the count that we have found in our data stream. And now we can save that. And here you can see on the left the images, and also here the bounding box of the machine learning model. And on the right, you can see how many filters are within our image. You can also use this result within the pipeline to write rules or use it as an input for other pipelines. So now once we've showed that, Marco will give you a few more slides of our current research, how we also enabled users to train new models that then can later be used within pipelines.
Ich bin nicht mehr Host.
Sorry. Ist wieder Host.
All right, thank you, Philip, for the demonstration. And now we will show you how you can actually build your own model with StreamPipes, which is only a sneak peek. It's an unreleased feature and part of our research, but we're excited to show you this feature. So what do we actually want to do with artificial intelligence for data streams? So we get this unlabeled amount of data, which is never ending. And now there are three different things that we actually want to do with it. First, we want to forecast what's going on in the future. So based on the past history of data, we want to find out what happens in the near or long-term future. The second thing we want to do is we want to find out, is the machine active at the moment or not? Or is a certain part currently produced or not? And third, we want to find out, for example, about a certain state or about a certain window that we classified as active, what was going on in there, or how was the quality of the part that was being produced, for example. That's why we differentiate between these two cases. The first one being the sliding window classification, where we want to classify inside of the window, of the current window, what is going on. And afterwards, after the session has finished, we want to find out, for example, how did the production process work out? Was it good? Was it bad? Which part was produced, for example? And yeah. So sliding window classification acts on a sliding window, and session window classification classifies a specified window in time. And how we do that is after we've connected our data sources, we can use a data lake sink to write the data to a database, which is then available in the Data Explorer. So in the Data Explorer, we have this graphical interface where you can interactively explore the data, and also where you can intuitively label the data. So basically you can add labels to the data with drag and drop. And after that, after we've labeled the data, we can then apply automated machine learning for each of these three machine learning tasks. Afterwards, after the AutoML has completed for either forecasting, sliding window classification, or session window classification, the best model that we found is available in the pipeline editor and can then be integrated into the pipeline. And we want to show you this feature now.
Okay, therefore I will show my screen again. And here we have another StreamPipes instance where we already have integrated some example data. So usually the workflow would be to connect a new asset or data source collect some data, and therefore we use our internal data lake. So this is a time series database where we collect the data and store it for some offline analytics. If I go to the Data Explorer, there you can explore this data. Here I have added data from the XDK sensor that I showed you before, where we have the X, Y, and Z values, and where we have the classes included, where we shook the data or the sensor and also throw it. Now it is possible to also label this data by hand. So via drag and drop, you can add new labels to the data and later export it. For the showcase, I already prepared several labels. And within here, you can see we have the shake label. So in this time, somebody shook the sensor. Also, it can be seen that there's several throw labels. So somebody threw the sensor. And here it can also be seen that it is quite hard to model such rules with declarative patterns. So here we leverage machine learning and use this already pre-labeled data as training data and train a machine learning model. We built an extension with the StreamPipes extension module with this model training application. So users can go here, and here we have those 3 different types of sensors or machine learning models, which Marco talked about before. So we have forecasting on the left, then we have the session window classification, where we classify each event within our event stream. And on the right, we have a session window classification, which we usually use in discrete manufacturing processes, where we want to wait till the process step is over and then classify the whole process step. For our example, we will show a sliding window classification. And in the first step, we have to select our data from the data lake. So here I take the shake data, which I showed you before. You can also set a step size. So if you want to classify each event, or for example, if you set it to 10, it will only classify every 10th event. Then when you go on next, you can say what is your target variable. In this case, it is the label from our event stream. So this was the background color in the visualization before. If I go to next, we can also set our timestamp. And now as a user, you can also say what kind of properties should be considered during the training process. So here you can also reduce the amount of data. For example, if you would also have temperature value within here, you can deselect it and only concentrate on those values which are relevant for the situation you want to train the model for. Then in the last step, you give it a name and you can start the training. Now in the background, we execute a training job in our training service, and you can monitor this training job over the user GUI here. So if I navigate to this training service, you can see there's a new training job that is currently done. This takes for this data set about 1 hour to train, but I also prepared one training beforehand. And here you can then, once the training is finished, you can monitor the results. So in the background, we are training multiple machine learning models and compare them. So here you see the prediction results of the test set, of the training set, the validation set, and the test set. And we also rank those models according to their accuracy. It is also possible to see the variable importance, so how important the individual properties or event properties were for the prediction. And then once this training is completed, you can go back to the pipeline editor, and then the model is available within the pipeline editor and can be used on your data stream. And that shows you how easy it also can be to train machine learning models and then deploy them into the system. And now my colleague has the last slide.
Yes. Thank you very much, Philip. And that was it from our talk. And if you have any questions, feel free to ask them now. And if you want to reach out to us, you can feel free to check out our website or message us directly. We are always happy to get in touch with interested people. Thank you very much.
Also, big thanks from my side, and thank you for listening to our talk, and we're happy to answer your questions.